welcome to another Math 4 Honors Arlington High School video. My name is Kirk Weiler, and today we're going to be doing Unit 1, Lesson number 3 on the Exponent Review. Let's get right into it, shall we? Alright, so in today's lesson what we're going to be doing is reviewing Essential Exponent Properties from Algebra 2 with Trigonometry. Now, in my mind, there's really two types of things with exponents. There are the definitions of exponents, and then there are also exponent properties. So let's fly through them really quickly, right? So going over here where we're talking about exponent definitions, right? Ooh, that's interesting. Let's change that back to blue. I don't really like the yellow so much. Erase. All right, so obviously the expectation is that you know that any quantity raised to the 0 power is equal to 1. It's also essential that you understand that when we raise something to a negative power, it's the same as dividing by the positive power. So, for instance, 5 to the 0 is equal to 1. On the other hand, 3 to the negative second is the same as 1 over 3 to the second, or 1/9, right? So that's the illustration of property 1. There's the illustration of property 2. You should also understand in letter 3 the equivalence between fractional powers and roots. That's exceptionally important. So if I had something like 9 raised to the 1/2, that's the same as the square root of 9, which is obviously 3. On the other hand, if we have some non-unit fraction, right, then what we need to understand is that that's the combination of both a root and an integer power. So for instance, if I had something like 5 to the 3/2, I can either think of that as the square root of 5 that was then cubed, or I can think about it as 5, which has been cubed, and then I took the square root of it. All right, so all of those are exponent definitions. Now, you don't really have to know the difference between a definition and a property, but you do have to be fluent with both of them. So let's take a look at those properties. All right, so the first property, maybe the most important property, is when we multiply two quantities that have the same base, and it doesn't matter whether that base is a variable or whether it's a constant, then what happens is we end up adding the powers. So 2 to the 3rd times 2 to the 5th is equal to 2 to the 8th, right? We add those powers. On the other hand, when we divide the two quantities, we subtract the powers. So 2 to the 5th divided by 2 to the 3rd is equal to 2 to the 5 minus 3, or 2 to the 2nd, right? On the other hand, when we take something that we have raised to a power and we raise it to another power, then we multiply the two powers. In other words, if I have 2 to the 3rd that is then raised to the 5th, then overall I have 2 to the 15th, 3 times 5, all right? As well, number 4 is very important, and this is going to show up quite a bit today. If we have a product that is being raised to a power, then that power actually distributes to the product. In other words, if I have something like 2x to the 5th, then that's equivalent of 2 to the 5th times x to the 5th, 2 to the 5th being 32, and x to the 5th being, well, x to the 5th. All right. The same is true if we have a division. So if we have a divided by b raised to the n power, then we can do both the numerator to the nth and the denominator to the nth. So if I had something like x divided by 2, and I was raising it to the 3rd, that would be the same as x to the 3rd divided by 2 to the 3rd, which would be x to the 3rd divided by 8. Now keep in mind, because powers and roots really are equivalent to one another, this would also hold with roots. If I had the square root of a divided by b, that would be the square root of a divided by the square root of b. Now number 6 is interesting because it's not actually a property, it's a non-property, if you will. One thing that exponents don't do is they don't distribute through addition or subtraction. So a plus b to the n is not a to the n plus b to the n generally, unless n is 1, and, well, then it is. But generally speaking, you don't want to see something like x plus y to the 5th and think that that is x to the 5th plus y to the 5th, because it's not. All right? That would be silly. If that were true, then I could say something like 2 to the 5th would be 1 plus 1 to the 5th which would be 1 to the 5th plus 1 to the 5th, but then that would be 1 plus 1, and that would just be 2. So that would be silly, right? That wouldn't make any sense. All right, now I'm going through these really quickly because we're going to launch into some review problems. Pause the video now if you need to and copy down anything you have to. Then I'm going to clear out the text, okay? All right, well, let's clear it out. This video is being brought to you in my lovely dining room with my mirror behind me and all sorts of things, but that's okay. We got to find the time to do them at some point. So let's move on and actually get into some problems, okay? All right, so exercise 1. Notice I specify here that I want you to do this without the use of a calculator, and I want you to evaluate each of the following numerical expressions. I'd like you to pause the video right now and take a shot at each one of these things, and then we're going to revisit them, okay? All right. Now, obviously, every single one of these is very, very easy without a calculator, but it wouldn't even make any sense. 27 to the 1/3. All right, well, what is that? That is, by definition, the same as the cubed root of 27. The cubed root of 27 is 3. And, of course, it's 3 because 3 times 3 times 3 is 27, right? So 27 to the 1/3 is 3. On the other hand, what is 9 to the negative 1/2? Well, the first thing I think I'm going to deal with, because you don't have anything like the negative 2 square root, right? What I want to do is actually get rid of that because you can't. That didn't work. Let's try that again. I want to get rid of that. Let me just make that medium in the future. So what we want to do is we want to get rid of the negative. In other words, the first thing I would do when thinking about this is rewrite it as 1 divided by 9 to the 1/2, right? That's that property that just says a to the negative n is the same as 1 divided by a to the n, okay? But now I can change that into a square root, all right? So I'll have 1 divided by the square root of 9, and that would be 1/3. Keep in mind that when I say that the square root of 9 is 3 as opposed to negative 3, that is by definition. If I wanted a negative in front of that square root, somehow that negative would have to be there. All right, so in other words, something like this, well, that's a whole different ball game. Okay, negative 9 raised to the negative 1/2. Anyway, that's not what we have going on here. All right, 16 to the 3/2. Well, this is a combination of both a root and a power. So what we've got here is we've got the square root of 16 cubed, or we've got 16 cubed that we've then taken the square root. Now, if you have to do this without a calculator, it's probably going to be easier to do this route first, right? Because we can easily take the square root of 16 and get 3. And then, of course, we can easily take the square root of 16 and get 4, and then we can cube it to get 64. It's a lot harder to do it this way simply because thinking about what 16 cubed is not the easiest thing in the world. You know, even if you're good with powers of 2, it's still not the easiest problem. All right, let's take a look at letter D, which is undoubtedly the messiest of them all, but can also be done in a variety of different ways. One way of doing this is just the straightforward brute force approach. In other words, we kind of take a look at what we did in letter B, and we rewrite this as 1 divided by 1/4 to the 5/2. Okay, well, that's no problem, right? Then I say to myself, all right, whatever, so that's going to be a combination of a square root and a 5th power, right? So maybe I do the square root of 1/4 raised to the 5th, right? Square root of 1/4 is 1/2. 1/2 to the 1/5 is going to be 1/2 times 1/2 times 1/2, etc., which will be 1/32. And 1 divided by 1/32 will be 32. All right? Now, there is another way of looking at it. You could look at 1/4 as simply being 4 to the minus 1. So if I have 1/4 to the negative 5/2, that would be the same as 4 to the negative 1 to the negative 5/2. And now we can use that property that says, well, why don't we just go ahead and multiply those two exponents? And that makes my life a lot easier because then I'll just have 4 to the 5/2, which will be the square root of 4 raised to the 5th, which will be 2 to the 5th, which will be 32. All right? Now the expectation here is that you can do all of these without a calculator. Now a common complaint is, yeah, but why should I do it without a calculator? I have a calculator, you know. Well, The primary reason why you want to be able to do these without a calculator is so that when it really counts, when you literally can't do it without a calculator because you don't know, you've got variables, let's say, instead of constants, you still are able to fluently apply these exponent laws. Anyhow, pause the video now if you need to, write down anything you have to, and then we're going to move on. All right. Hopefully that's good enough. Gave you enough time? Maybe? Who knows? Anyway, I'm going to clear this out, and then we'll move on. All right, let's take a look at exercise 2. Exercise 2, write each of the following quantities without the use of negative or fractional exponents, and then simplify if possible. So I'd like you to try both of these as well. Write each of these without the use of negative or fractional exponents, simplify if possible. Take a little bit of time to do this. You're not doing that much in these problems, okay? So don't overextend. All right, let's go through them. Now, I know that in class, a lot of students actually make a mistake with this one, so I'd like to actually write out a mistake here. A lot of students will look at this and they'll immediately go, oh, well, there's a negative exponent. Therefore, I'm going to rewrite this as 1 divided by 9, x to the 1/2. This is actually a large mistake. I can't even get into how big of a mistake it was going to be. I was going to circle it, but we'll just do it like this. The reason that this is such a huge mistake is that we have to remember our order of operations, right? Exponents come before multiplication. So that negative 1/2 exponent is only attached to the x. It is not attached to the 9. So in fact, the way we should look at this is the same as 9 times 1 divided by x to the 1/2. And that would be same as 9 times 1 divided by the square root of x, which is the same as 9 divided by root x. So it's very important that this is what you have instead of this particular wrong answer. A lot of people will have something like this, which is incorrect. On the other hand, in letter B, because we've used parentheses to group these two together, that 2/3 does apply to both the 8 and to the x. In other words, we have 8 to the 2/3 times x to the 2/3. Here, 8 to the 2/3 is the cubed root of 8. That's then squared. Why don't we figure that one right away? The cubed root of 8 is 2, and when we square it, we get 4. And then, of course, here, if we're going to write this without a fractional exponent, we can do it 2 ways. The standard way of doing it is to put the x squared under the cubed root symbol. This is more likely what you'll see rather than this, which is completely okay. In other words, actually having the cubed root of x that's then squared. Although these are both completely correct answers, this is the more standard way of having it written. All right? So very important when you're looking at an algebraic expression to keep your order of operations in mind. All right, pause the video now if you need to. Write down anything you have to. Then I'm going to clear out the text. All right, here it goes. Let's move on to exercise 3. We're going to move through these pretty quickly right now because this is review. Now the next skill is very important for later work in this course. It says write each of the following in power form, all right? i.e. a times x raised to the b. So something that you learned about in Algebra 2, albeit briefly, were what were known as power functions. Let me kind of write that right down here, power functions. Power functions are very simple but important functions. They have the form y equals a times x raised to the b, where a and b are constants. And these come in very simple forms like y equals 5x squared. They come in more complicated forms like y equals 1/3 x to the negative 1/2, right? All of these are power functions. So what we want to be able to do is take these kind of expressions and write them as a constant times x raised to a power. Important. So what I'd like you to do is consider that and work through each one of these. Be very careful with each one. Remember, I'm looking for a final answer that is a constant times x raised to a constant. All right, pause the video now and take a little bit of time to do this. All right, let's go through them. So, remember your fraction work. This thing is really 2 times 1 divided by the cubed root of x. All right, so let's deal with this. Well, what is that? Obviously, the cubed root of x, well, I shouldn't say it's obvious, but from previous courses, the cubed root of x is x to the 1/3, but all of this is then x to the negative 1/3. So in my final power form, I've got 2, a constant, times x raised to the negative 1/3. All right? Now, a lot of people will get that one right, but then will have trouble with letter B. Again, for very important reasons. A lot of people will rewrite this as 3 times x to the negative 5. But that's a little bit weird, don't you think? I mean, there's a 1/3 in this problem, and there's no 1/3 here. So that's actually an incorrect answer. In fact, the way I want to look at this again is think about it as 1/3 times 1 divided by x to the 5th. Now, as soon as I do that, it's actually relatively quick. That's my dog in the background playing with his chew toy. The reason it's relatively quick is that 1 divided by x to the 5th is simply x to the minus 5. So a letter B, 1/3 times x to the minus 5th. Now, letter C, we actually have to do a little bit more work, but we can apply that exponent property that says if I've got a quotient, a division, a divided by b raised to the n, then I can apply that power to both the numerator and the denominator. So that's what I'm going to do. I'm going to actually say I've got 4 to the 1/2 in the numerator, and I've got x to the 6th to the 1/2. Actually, let me write out this sort of intermediate step. Right, I've got x to the 6th to the 1/2 there. I'm going to get rid of a little bit of this just so I've got a little more room down here. Let me do some erasing. All right, back to my pencil. Well, 4 to the 1/2, remember that's just the square root of 4. And here I can use that property that says if I've got something raised to a power raised to another power, I simply multiply the powers. Right, so I get x to the 3rd. So I get 2 divided by x to the 3rd. And now I'm really back to a situation that's very similar to letter A. This is ultimately 2 times x to the minus 3. All right? Pause the video now if you need to write anything down. All right, let's keep going. I'm going to clear this out. Let's move on to exercise 4. Ooh, simplify each of the following and leave without any radicals. So I don't want any square roots or cubed roots or anything like that. And I want no variables in the denominator. So negative exponents are okay. Fractional exponents are okay. But variables in the denominator in this problem, or radicals, i.e. square roots, cubed roots, fourth roots, etc., are not okay. All right. So again, what I'd like you to do is pause the video now, take a little bit of time to work on both of these, and see what you get. All right, let's go through them. Now, in this particular problem, I think what I'm going to immediately do in order to use the properties of exponents is I'm going to change that cubed root into a 1/3 power. Now I'm going to use that property that says if I've got a product of two quantities raised to a power, I can raise both of those quantities to that power before I do the product. So I'm going to actually have negative 8 to the 1/3 times x to the 6th to the 1/3. Here we've really got the cubed root of negative 8. Now think about that, right? The cubed root of negative 8 is negative 2. Here I'm going to use that power that says that I multiply, or sorry, not that power, but that property that says that I multiply the two exponents. 6 times 1/3 is 2. So I have negative 2x squared. All right, now letter B looks a lot more daunting, right? So you just have to take your time, step by step. There's many different ways to do this problem. I think the first thing I'd do is totally ignore the y to the 4th. Nothing's really going on with it. But here what I'm going to do is I'm going to use two exponent properties at once. One thing I'm going to do is apply this exponent to both this, and I'm going to use the property that says I multiply the exponents. So x to the 3rd squared will be x to the 6th, y to the negative 2 squared will be y to the negative 4th, all divided by 2x to the minus 1. Now there's a lot of different places you can go from here. All right, we can use the associative property of multiplication to kind of swing this around and maybe help us out a little bit, right? So that we kind of group this and this together. And then I'll put that x to the, oops, that almost looks like a 6, not really. X to the 6th there, and that negative 1 there. Here, now we can multiply y to the 4th times y to the negative 4th to get y to the 0, right? We add the exponents. We'll deal with the y to the 0 in a little bit. Now we have to be very, very careful here. It would be very tempting to say that x to the 6th divided by x to the minus 1 is x to the 5th, but it's not. In fact, if we faithfully apply the exponent law that says that when we divide two quantities, we subtract their exponents, right? Then what we see is that that's going to be an x to the 7th. Then we're just left with that 2 in the denominator. Of course, my final step would be to recognize the fact that y to the 0 is 1. So I'll have 1 times x to the 7th divided by 2, or just simply x to the 7th divided by 2. That's it. Looks like a beast of a problem, but it actually simplifies down quite nicely. All right, pause the video now if you need to. Copy down any of this work. All right, I'm going to clear it out and we'll move ahead. All right, last little problem. It's important sometimes to recognize when what you're seeing on the page can be a little bit misleading. All right, notice it says, evaluate each of the following without using your calculator. All right, so for instance, here I've got what appears to be negative 5 squared. And I think most people would say, well, negative 5 squared is positive 25, right? It's negative 5 times negative 5. Unfortunately, again, when we think about our order of operations, right, we really have to look at this as negative 1 times 5 squared, right? If not, then it would be very, very hard to interpret something in letter C that looks like this, right? Think about this, negative 5 squared versus negative x squared. Right? Even the way that I say it is confusing. But this literally means negative 1 times 5 squared, so that would be negative 1 times 25, which would be negative 25. Now you might say, well, that's really misleading, all right? But then again, how would you show this if it weren't like that? I mean, I suppose you could do something like this. That would be a little weird, you know, and a little bit bulky with all the parentheses, all right? On the other hand, this truly is negative 5 times negative 5, right, which gives us positive 25. So what I'm trying to get at in this problem is that you need to be able to tell the difference between these two. Now, the good news is that mostly you need to tell the difference when it comes up in a context like this. And in most cases, when people see something like this, they interpret it correctly, right? Which is they interpret it as negative 1 times x squared and not, hey, take x, negate it, and then square it, right? That's this situation over here. Let me just erase that since it has nothing to do with this. So in fact, if I'm going to evaluate this when x is 2, then what I'm really doing is I'm squaring the 2, right, getting 4, then negating it and adding 7, which obviously just gives me positive 3. All right, that is a particularly tricky thing because even I, when I look at letter A, think of that as, well, yeah, it just looks like negative 5, the number negative 5 squared. But in fact, if we want to have something like the number negative 5 squared, we've got to have the negative 5 in parentheses. All right, well, pause the video now if you need to, and then I'm going to clear out the text and we'll finish up the lesson. All right, here we go. All clear. Let's finish up. So, it's absolutely essential for you to have control of the laws of exponents. Very, very important. We will be using them constantly, consistently in this course. You will get better at them almost by default. It's like learning how to use a screwdriver or a hammer. You know, when you first use any kind of a tool, it's sort of foreign and you're not using it necessarily for a purpose. In our course, we will have to use the laws of exponents for purposes other than just, kind of the manipulations that we did today. For now, though, let me just stop the lesson and thank you again for joining me for another Arlington High School Math 4 Honors lesson. Until next time, my name is Kirk Weiler. Keep thinking and keep solving problems.